Hey, it's Josie with Queen My Pawn. Today I'm going to be talking about an introduction to the Cartesian plane. The Cartesian plane was, or still is, part of Cartesian geometry, which Cartesius, or Cartesius, who is also known as Rene Descartes, created. So we have since then a lot of geometry and algebra that has been connected to each other. And the Cartesian plane is simply a system where you use two lines called X and Y to create shapes. It all starts with a simple line. And in this line, suppose that you have a number line, that this is just a simple number line. Then this could be 0, and that could be 1, that could be 2. The other way could be -1, the other way could be -2. We all know this to be a number line. So this point right here, everyone could agree that it's just the number 2. You can put it in parentheses and call it 2. So that would also be known as a singleton because it's single. But then Cartesius, or Rene Descartes, noticed that he could also draw a second line and intersect it with this one so that it looks something like this. And now you have two lines. So you have one going sideways and the other one going up. This could also be 1, 2, 3. And that could be -1 because it's going down, -2, and then -3. Same thing here. So does that mean that if on this first line we have the point 1, the other one could be 1, like this? Not necessarily. The value of 1 could also be connected to 2 or even 3. These are what we called pairs of numbers. This one would be called 1, 1 because you have ones on both lines. This one could be called 1, 2 because you have a 1 and a 2, and this one could be called 1, 3. But which one should come first? Should the one going up and down come first so that instead of 1, 3 looks like 3, 1? So there's some ambiguity there, and we don't know exactly what to do. So Cartesius, or Rene Descartes, created ordered pairs, because even though these are just pairs, they're not ordered and they could be put in any way, which is not good. But let's call them an ordered pair by adding an order. The first number will be called X, and the second number will be called Y. So a point like this will have X, Y in that order. So now the point is called an ordered pair. It's ordered, X has to come first. And since X is 3, the point could be called 3, comma, let's look at what Y is 1. So that would be 3, 1. And that's basically it. You can create multiple shapes on these lines. So I'm actually gonna put a new one here. And let's see. I'm gonna go ahead and open up, look for, there it is. So look at the Cartesian plane. And this is a much prettier Cartesian plane. So suppose that you have a point over here and a point over here and a point over here. And if you connect them, you could actually see that it does make a line, kind of like a diagonal line. And if you notice a cool pattern, you see that x is the same number as y. So you can even say that y equals x. And that's actually the name of the line. So you can create lines in Cartesian. There's other shapes you can create, like circles. For example, this is a circle of radius 3. And the way this would work, actually, let me create a radius 4 here. I think this will be an easier example to understand. This is a circle of radius 4. You have to go 4 from the middle to get to the edge. And the formula for this is x squared plus y squared equals 4. For example, if you pick a point over here, or actually, sorry, it's not equals 4, it's equals 16. If you pick a point over here, this point is the ordered pair for 0, and it's on the circle. So that means you plug in 4 squared here, plus 0 squared, and you should get 16. And it's the same over here at the point 0, 4. And over here, -4, 0, and the same one at the bottom. But it's also the same for a point over here. It's difficult to tell exactly what number that is. But if you plug in that number, the numbers in the ordered pair into that equation, you will get 16. Something more clear is maybe this one, because it's clear that that's 2. So if we have y equal 2, then you have x squared plus 4 equals 16. And solving for x, you should get x equals the square root of 12, which has to be somewhere between 3 and 4. And obviously is, because the square root of 9 and the square root of 16, 3 and 4, and 12 lies somewhere between there. You can draw many other shapes with it. So that's a brief introduction to the Cartesian plane. I hope you liked it. We'll be doing a lot more with it, especially working with lines, because once you get the foundation of working with lines, then everything is very simple. So hope you enjoyed, and make sure to subscribe. Thanks for watching.